3.2 Definition of Limits. In the last section we discussed average velocity, and we said that if you make the time intervals shorter and shorter, you get a better and better approximation of the instantaneous velocity. And that process of making the time intervals shorter and shorter, that process is a limit process. We also discussed secant lines. When you have a graph, if you draw a line that crosses the graph at two places, you have a secant line. And secant lines are used to approximate tangent lines. Suppose I'd like to know the slope of the tangent line when t is equal to 1. I don't know what that slope is because a tangent line only crosses a graph at one point. It only touches at one point. So I use a secant line to approximate a tangent line. Here I am at the interactive ebook, and I just wanted to show you the green line is the secant line. And notice that as t is right here at 2.5, as t gets closer and closer to our target point of 1, you're going to see the green line move. So t gets closer and closer to 1, and you can see the green line getting more and more in line with the red line, which is the tangent line. And so the green line does a better and better job of approximating the red line. Let's do that again. The green line way out here. But if I make the 2 points closer and closer, the secant line, the green line, approximates the tangent line better and better and better. And that's a limiting process. As t was getting closer and closer to 1, the green line was doing a better and better job of approximating the red line. And the slope of the green line was getting closer and closer to 64. And so we say that the slope of the secant line as t approaches 1 is equal to 64. And that means that you can get as close to 64 as you want just by making sure that t is close enough to 1. And I could have demonstrated this using a table. T is getting closer and closer to 1, and the slope of the secant line is getting closer and closer to 64. The limit of f of x as x approaches a is equal to L. That means that you can get as close to the value L as you want just by making sure that x is close enough to a. There are three ways to find a limit. You can graph your function, you can make a table, or you can use analysis. For example, look, f of 1 is equal to 1. What is the behavior of the function as x gets closer and closer to 1? The function is getting closer and closer to 2. What is f of 2? Well, at 2, the function has a value of 5. But what is the behavior of the function as x gets closer and closer to 2? The behavior of the function is 3. What is f of 3? Well, f of 3 does not exist. There's just a big hole there. But what is the behavior of the function as x gets closer and closer to 3? Well, the function is getting closer and closer to 4, and so the limit of the function as x approaches 3 is equal to 4. Sometimes we like to specify which direction we are coming from as we get closer to a target number. For example, if I am approaching 1 from the left, I write x arrow 1 with a little negative above it. And x arrow 1 with a little plus above it means x is approaching 1 from the right. In the case of calculating the secant lines, the values of t were greater than 1 while getting closer to 1. A more accurate statement than t is approaching 1, which I previously made, would be to say that t is approaching 1 from the right, because all these t values are larger than 1, and t is getting closer and closer to 1. And so I would say the limit of the slope of the secant line as t approaches 1 from the right is equal to 64. What is the behavior of f as x gets closer and closer to 1 coming from the left? Let's do an example. Suppose I'd like to find this limit. If x is approaching 1 from the left, x is less than 1, but getting closer and closer to 1. And so my table would look like this. And when I fill it out, I find that the limit is equal to 2. What is the behavior of f as x gets closer and closer to 1 coming from the right? Well, let's do this example. So x is approaching 1 from the right. So x is larger than 1 and getting closer and closer to 1. And so I use perhaps this table. These x values are all larger than 1 and getting closer to 1. And when I fill out the table, I see that the limit is equal to 2. The limit of the function as x approaches 1 from the left is equal to 2. The limit of the function as x approaches 1 from the right is equal to 2. The left hand and right hand limits agree. Since the left hand and right hand limits agree and are both equal to 2, we say that the limit of the function as x approaches 1 is equal to 2. Let's look at a new example. What is the domain of this function? The domain is all real numbers except 2. Can we find the limit of the function as x approaches 2? To find the limit, we're going to use a table, and we're going to find the limit as x approaches 2 from the right and from the left. Coming from the left, I get a value of 3. Coming from the right, I get a value of 3. The limits agree and are both equal to 3. And so the limit of the function as x approaches 2 is equal to 3. We could also graph the function to find the limit of the function. As always, you do need to be aware of the capability of your particular technology. As we said, this function does not allow the value of x equals 2. And yet, when I go to graph it, I get a graph like this. This computer-generated graph is inaccurate because f is undefined at x equals 2, and yet it shows that, that x has a value of 2. A more accurate graph would put a hole when x is equal to 2. Well, if you do use technology, you're going to come to the same conclusion. As x approaches 2 from the left, the function is getting closer and closer to 3. As x approaches 2 from the right, the function is getting closer and closer to 3. And so we conclude that the limit of the function as x approaches 2 is equal to 3. What about this limit? As x approaches 2 from the left, the function is getting closer and closer to 4. As x approaches 2 from the right, the function is getting closer and closer to 1. The limit of f of x as x approaches 2 does not exist because the left hand and right hand limits do not agree. What about this function? What is the domain? The domain is all real numbers except x equals 0. What is the limit? The limit does not exist, and this is because the function cannot settle on any one value. In fact, as x approaches 0, the function oscillates faster and faster. And so we say that the limit does not exist. Have a great day, and I'll see you next time.